Hello, students. Today, I'm going to do some revision with you on the reaction mechanisms. I will focus on those mechanisms that reproduce the racemic mixture, okay? Okay, let's start. Now first, what's meant by racemic mixture? Racemic mixture, of course, is a mixture, right? Mixture that contains equal amount of a pair of enantiomers. Okay, that means an enantiomer with its mirror image. Okay, so basically, as we learned that, for example, if we have this one, A, B, C, D, and this is a chiral carbon. Okay, and then its mirror image will be A, D, C, B, right? So now this is a pair of enantiomer, and each carbon atom is bonded with 4 different atoms or 4 different groups of atoms, okay? So they can rotate the plane of polarized light at the same extent but opposite direction. Okay, I believe you already recited this definition. Okay, if you remember, as I told you, light originally it is unpolarized. Okay, which means the oscillation is basically in all directions. Okay, and of course it's perpendicular to the propagation direction. It's physics stuff, but anyway, after passing through a polarizer, it will be polarized. So for molecules which contains a chiral carbon, it can rotate the plane of polarized light, okay? Now, an enantiomer and its mirror image, they are a pair of enantiomer, right? And then they can rotate the plane of polarized light in the same extent opposite direction. For example, this one can rotate the plane of polarized light by 30 degrees. And this one can rotate the plane of polarized light by 30 degrees as well, but except the left one is clockwise. It rotates the plane of polarized light clockwise, but this one is anti-clockwise, okay? Now, so think about if a mixture that contains equal amount of these two, okay, then overall the mixture will not rotate the plane of polarized light because they cancel out. It's like you pull an object to the right with 3 Newton and to the left with another 3 Newton. So eventually this object doesn't move, okay? So if they contain equal amount of a pair of enantiomers, then it is the racemic mixture. The reason why I talk about this is in your syllabus, there are 2 mechanisms that lead to the production of racemic mixture. And if you really look at the worksheet I gave you lately, there's a question asked you to explain why. So that's why I think there's a need for me to clarify this concept. So one of them is SN1. The other one is the nucleophilic addition reaction. They both reproduce racemic mixture, okay? Because both of them will lead to a planar molecule, okay, which can be the intermediate or which can be the original reactants. In the next video, I will talk about one by one why SM1 and why nucleophilic addition reaction can lead to the production of racemic mixture. I hope you still remember what SM1 is. We have SN1 and SN2. They are the nucleophilic substitution of halogenoalkane. Okay? Do you understand what I'm saying? And I can also take this chance to explain SN2 as well. SN2, okay? So as a revision with you guys. Okay, see you in the next video. Bye bye. Bye bye.